Tonight, we're turning our attention toward one of the most quietly universal experiences the sleeping mind has ever produced. Why does the sleeping brain protect you from something it invented? And what does that reveal about the mind that dreams? Science tells a different story than the one most people have been told about their own nightmares. And that story begins right here, with you, exactly as you are. Welcome to Psychology for Sleep. Wherever you are, right now, perhaps already under the weight of a blanket, eyes heavy, the day beginning to release its hold, allow yourself this particular kind of stillness. We'll drift through the corridors of 100 relaxing dream facts about the sleeping mind. From the neuroscience of why the brain wakes you before the dream ends, to the emotional architecture of the stories you tell yourself each night, to the quiet science of why dreaming is one of the most important things a human being can do. These quiet journeys through the dreaming mind build a community of people who have stopped being afraid of the night. A gentle like, subscribe, or a soft share helps other restless minds find their way here. People who are still searching for the particular kind of peace that comes from understanding what is happening while they sleep. Your presence here is already part of that, one dreaming soul at a time. Let yourself settle completely now. Feel your jaw soften, your shoulders drop. There is nothing you need to solve tonight, nothing you need to protect yourself from. You can let the thoughts of the day dissolve. Like that half second between the dream and waking, when you don't yet know which world you're in. And then, gently, you are simply here. Your mind already knows how to do this. It has been doing it every night of your life. Close your eyes and breathe deeply. You're where the dream still clings to the edges of waking. Let your mind dissolve into the quiet. And now we begin. Almost every human being alive has had the experience of waking up right before something terrible happens in a dream. Before the fall reaches the ground, before the impact, before the final moment. It happens so consistently across so many cultures and so many different kinds of lives that researchers have spent decades asking a simple question: why does the brain stop itself? The answer begins not with fear, but with architecture. The dreaming brain is not broken when this happens. It is, in a very precise sense, working exactly as it was designed to blank dosto. Tonight, we follow that design all the way to its quiet center. Dreams happen in a stage of sleep called REM, rapid eye movement sleep. During REM, the eyes move beneath closed lids. The brain becomes nearly as active as it is during waking life, and the body enters a state called REM atonia, a kind of temporary paralysis that prevents you from physically acting out what you dream. This paralysis is not accidental. It is one of the most elegant protective mechanisms the nervous system has ever evolved. Without it, the stories the brain tells at night would spill into the physical world with every twitch and sprint and desperate run through a dark landscape. The brain does not experience sleep as a single continuous state. It cycles through distinct stages, roughly every 90 minutes throughout the night. Each cycle includes lighter sleep, deeper slow-wave sleep, and then REM, the stage where most vivid dreaming occurs. In the early part of the night, the cycles are shorter and the REM periods are brief. By the early morning hours, the REM periods stretch longer, sometimes reaching 30 to 45 minutes in a single stretch. This is why the most elaborate, emotionally complex dreams tend to happen just before waking. The part of the brain most active during dreaming is the limbic system, the cluster of structures responsible for emotion, memory, and survival responses. The amygdala, which processes threat and fear, is especially active during REM sleep. In many ways, the emotional brain runs the dream. The prefrontal cortex, which handles rational thought and logical judgment, becomes much quieter during REM sleep. This is why dreams feel so real. The system that would normally say this cannot be happening is quieter than usual. The system that says this matters, pay attention, is louder than ever. Researchers have found that the amygdala responds to threat in a dream with a chemical signature very similar to how it responds to real threat while awake. The stress hormones, the activation patterns, the emotional intensity, these are not symbolic versions of fear. They are the same fear, running through the same hardware. This is the foundation of tonight's central question. If the brain cannot chemically distinguish a dream threat from a real one, what happens when that threat reaches its logical conclusion? The experience of waking abruptly before a dream reaches its most frightening moment is so common that psychologists have a name for it. It falls under the broader category of REM arousals, brief awakenings that interrupt REM sleep in response to emotionally intense content. The most common triggers include falling from a great height, being chased, confronting violence, or facing the direct experience of dying. What these scenarios share is not their content, but their emotional intensity. They are scenarios the brain classifies, even in sleep, as requiring a response. One widely discussed explanation for why the brain wakes you before the dream's fatal conclusion is rooted in the biology of survival. The amygdala does not understand the difference between a simulated threat and a real one. When the threat level in a dream reaches a certain threshold, the amygdala initiates a cascade, the same cascade it would initiate if the threat were happening in the waking world. Part of that cascade is arousal, waking up, the oldest part of the brain, doing what it always does, choosing life. Dreams of falling are among the most universally reported across cultures. Researchers studying cross-cultural dream patterns have found that falling dreams appear consistently in populations from vastly different backgrounds, languages, and lived experiences. This suggests that the falling dream is not a product of culture or learned behavior, but something closer to a biological constant. One explanation involves the hypnic jerk, the sudden involuntary muscle contraction that many people feel as they drift towards sleep. Some researchers believe that during this transitional moment, the brain briefly misinterprets the body's relaxation as a fall and generates a dream fragment to match the sensation. The hypnic jerk has a technical name, a hypnagogic twitch, meaning a small muscle contraction at the threshold of sleep. It occurs as the brain hands over control from conscious monitoring to the slower rhythms of early sleep. During this transition, some researchers suggest the motor system fires one last brief signal, possibly a kind of biological double check. Are we really safe enough to let go? The sensation is so brief and so universal that most people never question it. But it is, in its own quiet way. The body asking the same question, the brain will ask throughout the night. So the question at the heart of tonight's journey is already beginning to take shape. The brain that dreams is also the brain that protects. These two functions do not run in separate systems. They share the same structures, the same chemistry, and the same fundamental commitment to survival. When a dream becomes threatening enough, the protection mechanism interrupts the story. Not because the dream was real, but because the brain's most ancient layer cannot afford to treat it as if it might not be. This is already the beginning of an answer to why you wake up before you die in a dream. Not everyone wakes up before the dream's worst moment. Research into dream recall and dream content suggests that a meaningful portion of people report dreams that do continue through difficult or violent events, including dreams in which they experience what feels like death or serious injury. What determines whether the brain intervenes or allows the dream to continue is not fully understood. Factors, including individual stress levels, emotional regulation capacity, sleep quality, and the overall architecture of that night's REM cycles, all appear to play a role. The intervention is not automatic. It is, in a sense, calibrated. The content of dreams is shaped by the emotional experiences of waking life, but not in a simple or literal way. The brain does not replay the day like a recording. It recombines. It extracts emotional themes, strips them of their specific context, and generates new scenarios that carry the same emotional weight. This process is known as affect-based dream generation. The brain asks, in effect, what was the emotional signature of today? And then it builds a story around that signature, often using imagery that is strange, fragmented, or completely unrelated to the actual events of the day. One function of this emotional recombination is believed to be memory consolidation. During REM sleep, the brain processes the emotional content of recent experiences, separating the factual memory from the emotional charge attached to it. This may be one reason why sleep after a difficult or emotionally intense experience can help reduce the distress associated with the memory over time. Research from multiple sleep neuroscience centers has continued to refine this understanding, with recent work suggesting that REM sleep may be especially important for processing social and emotional information, the kind that is most likely to generate vivid, emotionally intense dreams. The stories the brain tells during dreams follow a loose narrative logic, not the strict logic of waking thought, but a kind of emotional coherence. Characters shift, locations blend, the rules of physics relax, but the emotional through line tends to remain consistent. If a dream begins with anxiety, it tends to sustain that emotional register even as the specific content shifts around it. This is why a dream that starts with something as mundane as being late for a meeting can escalate, through a sequence of associative leaps, into something much more threatening. The content follows the emotion, not the other way around. Researchers have found that the brain's narrative system, the collection of structures responsible for constructing stories and making sense of experience, is active during dreaming in ways that closely mirror its activity during waking storytelling. This means that when you dream, you are not passively receiving images. You are actively generating a story. The brain is the author and the audience, simultaneously, and like any story, the dream has momentum. It moves towards something, even if that something is interrupted before it arrives. The question of whether people actually experience their own death in dreams has been difficult to study. precisely because the most intense versions of these dreams often result in the sleeper waking before the moment is reached. What researchers can study are the reported experiences immediately before waking, the sensations, the cognitive state, the emotional register. What these reports consistently show is not terror in its most acute form, but something closer to suspension, a moment of absolute stillness, a sense that something is about to resolve, followed by the abrupt return of waking consciousness. The moment of waking from an intense dream is associated with a distinct neurological signature. The transition from REM sleep to wakefulness involves a rapid shift in brain activity, a surge of faster, higher frequency waves that interrupt the slower rhythms of REM. This transition can happen within seconds. In the seconds after this transition, the brain is in a brief state of confusion, not yet fully in waking mode, but no longer generating the dream. This is the moment when the dream feels most vivid, most present, and most real. And then, within moments, it begins to fade. Dream recall is not random. Research consistently shows that people are more likely to remember dreams they wake from during or immediately after REM sleep. This is why waking during the later hours of the night, when REM periods are longest, increases dream recall significantly. But the content that is most likely to be remembered is also the content that is most emotionally intense. Neutral dreams fade quickly. Frightening dreams, emotionally significant dreams, and dreams with unresolved narrative tension tend to linger longer in waking memory. The brain does not store dreams the way it stores waking memories. Dream memories are encoded weakly and are susceptible to rapid interference from waking experience. Within 5 minutes of waking, most of the content of a dream is gone. Within 10 minutes, the vast majority is inaccessible. This is not a failure of memory. It is, most researchers believe, a deliberate feature. If every dream were remembered with the same clarity as a waking experience, the distinction between what happened and what was dreamed would begin to blur in ways that could be genuinely disorienting. Some researchers have proposed that the act of waking before the dream's fatal conclusion serves an additional function beyond simple protection. By interrupting the dream at its most intense moment, the brain may be ensuring that the emotional content of the experience is not fully processed as a completed event. An event that resolves, that ends, is stored differently than an event that remains unfinished. Research into memory suggests that incomplete experiences tend to occupy more cognitive space than completed ones. A dream that ends before its conclusion may, in this sense, stay with us differently than one that reaches its end. Lucid dreaming, the experience of becoming aware that you are dreaming while still inside the dream, offers a rare window into what happens when the dreamer is conscious enough to change the dream's direction. People who practice lucid dreaming report being able, with varying degrees of success, to alter the course of threatening dream scenarios, to choose not to fall, to turn and face what is chasing them, to transform the threat into something neutral. In these cases, the waking protection mechanism may be bypassed entirely. The dreamer, having recognized the nature of the experience, no longer needs the brain's emergency exit. Research using neuroimaging during reported lucid dream states shows increased activity in the prefrontal cortex, the area that is normally quieter during REM sleep. This suggests that in lucid dreams, the rational, self-monitoring system partially reactivates, allowing the dreamer to observe the dream from a position of partial awareness. This increased prefrontal involvement may be one reason why lucid dreamers report a different emotional texture in their dreams. Less raw fear, more curious observation. The brain, when it can see the story for what it is, responds differently to its own inventions. Children experience more nightmares than adults. On average, research into developmental sleep patterns suggests that nightmare frequency peaks in early childhood and gradually declines through adolescence. The leading hypothesis is that this pattern reflects the development of emotional regulation capacity. As the brain matures and the prefrontal cortex develops more sophisticated connections to the amygdala, the emotional intensity of dream content gradually becomes more manageable. Young children, whose prefrontal amygdala connections are still developing, may simply not have the neurological capacity to regulate the emotional intensity that the dreaming brain can generate. Recurring nightmares, severe enough to disrupt sleep, and daytime functioning affect roughly 2 to 6% of the general population. Among people with post-traumatic stress disorder, research suggests that between 50 and 70% experience trauma-related nightmares regularly, a number that rises still higher among combat veterans and others with histories of severe trauma. The nightmares associated with post-traumatic stress have a distinctive quality. They tend to be more repetitive, more faithful to the actual traumatic event, and less susceptible to the normal fading that occurs upon waking. They are, in many ways, a mirror of the difficulty the brain is having in completing the emotional processing that REM sleep normally accomplishes. And so the picture is already becoming clearer. Even in these first 25 facts, the dream is not a passive event. It is the brain actively generating experience, emotional, narrative, and physical experience. In the absence of the external world and the protection mechanism that wakes you before the dream's worst moment is not a sign of weakness or failure. It is the oldest part of your mind insisting on the same thing. It has always insisted on that you continue, that you wake, that you are still here. This is the first outline of tonight's answer. Let's pause here for a moment. Every cell in your body knows how to sleep. This state, the one you're settling into right now, has been repeated millions of times before you were born. In the bodies of every ancestor who ever rested, every creature who ever closed their eyes against the dark and trusted the night to hold them. You are doing the oldest thing a human body knows how to do. Your brain is already sorting what it needs. Your muscles are already releasing the tensions you have been carrying. Your breath is already finding its slowest, deepest rhythm without you asking it to. There is nothing you need to do right now. The body knows this. It has always known. Now we continue. The dreaming brain operates with a different relationship to time than the waking brain. Most people assume that dreams run in real time, that a 5-minute dream takes 5 minutes to experience, but research into dream duration and subjective time suggests this relationship is more complex. Some studies suggest dreams do run close to real time during REM sleep. Others indicate that certain types of dream content, particularly very complex or emotionally dense sequences, may compress or expand subjective time in ways that are difficult to measure from the outside. The experience of time in a dream is, like so much else about dreaming, partially generated by the dreamer. The emotional content of dreams is not equally distributed throughout the night. Research has consistently shown that REM dreams in the first half of the night tend to be milder in emotional tone, more associative, more loosely structured, more likely to incorporate fragments of recent waking experience. As the night progresses and the REM periods lengthen, the dreams become more emotionally intense, more narratively complex, and more likely to involve threat, conflict, or emotionally significant interpersonal scenarios. By the last REM period, before waking, the brain has, in a sense, worked its way up to its most elaborate productions. The brain regions involved in generating emotional dream content are deeply interconnected with the regions involved in memory. The hippocampus, which plays a central role in converting short-term memories into long-term storage, is active during REM sleep, contributing fragments of recent experience to the dream narrative. But the hippocampus does not transfer memories intact. It contributes fragments, edges, emotional tags, and associative links. The dream is assembled from these pieces in ways that often feel surreal or illogical to the waking mind, but make perfect emotional sense to the sleeping one. Research using high-resolution neuroimaging has shown that the patterns of brain activity during REM sleep replay, in a compressed and reorganized form, the neural patterns that were active during emotionally significant waking experiences earlier in the day. This replay is not a simple repetition. It is more like a rehearsal, the brain running through the emotional and associative structure of an experience, testing different connections, potentially integrating the experience into a broader network of meaning. The insula, a region of the brain associated with bodily awareness and the experience of physical sensation, is also active during dreaming. This is why dreams can feel not just visually vivid, but physically real. The sensation of falling, the physical impact just before waking, the feeling of cold or heat or pain within a dream. These are not metaphors. They are the insula generating bodily experience in the absence of the body's actual input. This is one reason why the moment before waking from a falling dream often includes a genuine physical sensation in the chest or stomach. The body, at that moment, is responding to what the brain is generating. The phenomenon of dying in dreams, or nearly dying, takes several recurring forms in reported dream content research. The most common include falling, drowning, being killed by another person, experiencing a vehicle accident, and being buried or trapped. What these scenarios share is not their external form, but their internal structure, a situation in which the dreamer's continued existence is in question. The brain, faced with its own narrative construction of a threat to survival, responds with the same chemistry it would use for an actual survival situation. The emotional system does not grade threats on a scale of real to imagined. Some research into near-death experiences, the vivid perceptual experiences reported by some people following cardiac arrest or other life-threatening events, has noted a curious overlap with dream content. The feelings of floating, of moving through darkness toward light, of encountering significant figures, of profound emotional clarity. These share structural similarities with the most intense REM dream experiences. This overlap has led some researchers to speculate that the brain, under extreme physiological stress, may activate some of the same neural circuits involved in REM dreaming. This remains an area of active and careful investigation, not a settled conclusion. But the overlap is worth noticing quietly. The concept of threat simulation theory, developed by sleep researcher Antti Revonsuo, proposes that one of the primary evolutionary functions of dreaming is to simulate threatening situations, allowing the dreamer to practice the perceptual, emotional, and cognitive responses needed to survive real threats without the actual risk of harm. Under this theory, nightmares are not a malfunction. They are the system, doing exactly what it evolved to do, generating the most realistic possible simulation of the most dangerous possible situations, so that the organism is better prepared to navigate them if they occur in waking life. Threat simulation theory has found support in studies of dream content across different cultures and populations. Threatening events appear consistently in dream content across diverse groups, often at rates that are disproportionate to the actual frequency of such events in the dreamer's waking lives. This suggests that the dreaming brain is not simply replaying lived experience, it is running scenarios that are more extreme, more dangerous, and more emotionally intense than ordinary waking life, stress testing the emotional system, pushing it further than reality currently demands. The most universal dreams, it turns out, share the same ancient grammar, only the words change from one life to the next. If threat simulation is one of the brain's dreaming strategies, the moment of waking before the dream's fatal conclusion may represent the simulation reaching its limit. The system has generated a scenario so extreme that the protective override activates. The simulation has served its purpose. The emotional and cognitive rehearsal has occurred. And now the brain's safety mechanism brings the session to a close. You wake up not because the dream failed, but because it succeeded. The amygdala's role in dream generation has been studied extensively in recent years, using neuroimaging technology that can observe brain activity during sleep with increasing precision. What these studies consistently show is that the amygdala is not simply reactive during REM sleep. It is actively participatory in the narrative construction of the dream. In other words, the amygdala is not just responding to threatening content in the dream, it is helping to generate that content in the first place. The emotional system is not a passenger in the dream. It is, in large measure, the driver. This active role of the amygdala in dream generation has implications for understanding why people with heightened amygdala reactivity, including people with anxiety disorders, post-traumatic stress, or significant life stress, tend to experience more frequent and more intense nightmares. The system that generates threatening dream content is the same system that is, during waking life, most sensitized to threat. In this sense, the nightmares of an anxious person are not random or arbitrary. They are the precise output of a brain that has been calibrated by experience and by biology to treat the world as more dangerous than average. The dream system reflects the waking system with faithful accuracy. The question of whether animals dream has moved significantly closer to an answer in recent years. Research using neuroimaging and electrophysiology in multiple species, rats, octopuses, birds, and others, has found evidence of REM-like sleep states and replay of waking experience during sleep across a wide range of animals. Recent research has provided some of the most detailed evidence yet that dreaming, in some form, may be widespread across the animal kingdom. If the threat simulation function of dreaming is real, then the evolutionary advantage it provides would have been available to many species long before humans arrived. Dreams may be among the oldest forms of mental experience. One aspect of the dreaming experience receiving growing research attention is the role of the default mode network. This is a group of brain regions that activate when the mind turns inward. During imagination, daydreaming, or self-reflection, these regions become less active when we focus on the outside world and more active when we are thinking about ourselves, our memories, and our relationships. The default mode network is highly active during REM sleep, suggesting a deep connection between dreaming and the kind of spontaneous, associative, inward-directed thinking that characterizes waking imagination. The dreaming mind and the daydreaming mind may be closer relatives than they appear. Halfway through this phase of our journey, the picture is deepening in a way that feels, perhaps, quieter than expected. The brain that wakes you before you die in a dream is not acting out of malfunction or excessive caution. It is operating from the same architecture that has always governed survival, an architecture so ancient and so consistent that it runs whether you are awake or asleep, whether the threat is real or imagined. And there is something deeply restful in that understanding. The brain on your behalf, even in sleep, especially in sleep, you're still here, still listening, still somewhere between thinking and resting. Take one slow breath. Your brain is doing exactly what it was built to do tonight. We'll keep going together. Gently. The act of waking from a dream is not instantaneous. Research using high-density EEG recording has shown that the transition from REM sleep to waking involves a cascade of neural events that unfolds over several seconds. During this cascade, the brain is in a transitional state, neither fully dreaming nor fully awake. This transitional state is known as sleep inertia in its early form. It is the reason why, in the moments just after waking from an intense dream, the emotional residue of the dream can feel so vivid, so present, so difficult to separate from waking experience. The emotional residue of a dream can persist well beyond the period of sleep inertia. Research into what is sometimes called dream effect spillover has shown that the emotional tone of a dream, particularly a negative or frightening dream, can influence mood, cognitive performance, and emotional reactivity for hours after waking, even after the specific content of the dream has been forgotten. This means that the brain's overnight emotional processing leaves traces in the waking day. The dream you no longer remember may still be shaping the way you respond to the first difficult moment of the morning. Not all threatening dreams end in abrupt awakening. A significant portion of people report experiences in which they do witness their own death within a dream and do not immediately wake up. What follows, in many of these reports, is not darkness or termination, but a continuation, a different scene, a different perspective, or simply the dream moving on. This finding complicates the simple version of the protective awakening story. The brain does not always choose to interrupt the dream. Sometimes, it allows the narrative to reach its conclusion and then continues the dream from a different vantage point. The death in the dream is not the end of the dream. In many cultural and spiritual traditions around the world, dying in a dream has been interpreted as a sign of transformation, transition, or renewal rather than literal threat. Certain traditions of dream analysis interpret dream death as a symbol of psychological change, an old aspect of the self-giving way to something new. This interpretation is not a scientific claim, and tonight we hold it gently as what it is, a human response to a universal experience, a layer of meaning that many people have found useful. Science and meaning are not the same thing, but they can travel together. The role of personal narrative in shaping dream content is significant and underappreciated. Research into what is called the dream continuity hypothesis suggests that the content of dreams closely mirrors the concerns, préoccupations, and emotional dynamics of the dreamer's waking life. Not literally, not as a direct replay, but thematically, a person who is navigating a significant transition in waking life, a job change, a relationship shift, a loss, tends to generate dreams with themes of transition, uncertainty, and movement. The brain does not dream about what happened. It dreams about what it is still trying to understand. The relationship between waking anxiety and dream content has been one of the most consistently replicated findings in dream research. People who report higher levels of daytime anxiety consistently report more threatening, more emotionally intense, and more frequently disturbing dream content. But the direction of this relationship is not fully understood. Anxiety may generate threatening dreams. Threatening dreams may sustain anxiety by preventing the emotional processing that would otherwise reduce it, or the two may be aspects of the same underlying neural state, expressing itself differently across the sleeping and waking portions of life. One of the most promising therapeutic approaches to recurring nightmare disorder is image rehearsal therapy, a technique in which the person identifies a recurring nightmare, creates an alternative version of the dream with a different ending, and rehearses this new version during waking hours. Research has shown that this approach can reduce nightmare frequency and intensity in many people, including those with post-traumatic stress-related nightmares. The American Academy of Sleep Medicine recommends it as a primary treatment for nightmare disorder. The brain that generated the nightmare is the same brain that can be guided, with patience, toward a different story. Research into the neuroscience of nightmare therapy has found that successful treatment is associated with measurable changes in the brain's response to threat during sleep. The amygdala activity that previously surged in response to nightmare content becomes less reactive over the course of treatment. The prefrontal amygdala connection, the circuit that allows rational processing to modulate emotional response, becomes stronger. Healing from nightmares is not just psychological, it is neurological. It is structural. The brain, given the right conditions, rewires itself towards safety. The experience of sleep paralysis, the state in which a person wakes briefly during REM sleep but the body's temporary stillness has not yet lifted, offers a different window into the relationship between dreaming and threat perception. During sleep paralysis, people often report vivid hallucinations, frequently threatening in character. a presence in the room, a weight on the chest, a figure at the edge of vision. These hallucinations are the dream system still partially active, while the waking mind is already alert. The protection mechanism is generating imagery in a brain that is simultaneously aware enough to be unsettled by it. It is one of the most uncanny experiences the sleeping brain can produce. Halfway through our 100 facts, the answer to tonight's central question is taking a very clear shape. The brain that wakes you before you die in a dream is the same brain that generates emotional experience, processes memory, simulates threat for practice, and maintains the story of your waking life. These are not separate systems with separate agendas. They are one system, doing many things at once. And the most fundamental thing that system does, at every moment, whether you are awake or asleep, is insist that you continue. That insistence is not something to be afraid of. It is something to be grateful for. And let's pause here for just a moment. The memory you believe most strongly, the clearest image you have of something that happened, is actually reconstructed each time you recall it. Your brain rebuilds it, adjusts it, softens some edges, sharpens others. It is not a recording, it is a living thing. Right now, as you lie here, your brain is rewriting the day. Tonight is part of that draft. The events that seemed too large to hold this evening are being gently sorted, scaled, and filed in ways you will not be conscious of. You don't need to help with any of this. It is already happening. Now we continue the journey. The brain's commitment to survival during sleep extends beyond the simple production of threatening dreams. The sleeping brain also monitors the physical environment for genuine threats, meaningful sounds, a name being called, a baby crying, a smoke alarm, can penetrate sleep and trigger waking even from deep stages of sleep. This selective monitoring means that even in its most restful state, the brain has not gone off duty. It is maintaining a quiet vigil, one sensitive enough to let you sleep through traffic, but alert enough to respond to the specific sound of your own name. The brain's selective attention during sleep has been studied using EEG recordings of people sleeping in environments with varying types of sound. What these studies reveal is that the sleeping brain continues to categorize sounds, distinguishing between meaningful and non-meaningful signals. Even during deep sleep stages, the brain does not simply reduce all input uniformly when you sleep. It filters with remarkable precision, allowing most of the world to pass through while keeping watch for the specific categories of information that matter most. The relationship between daytime emotional experience and that night's dream content follows a pattern that researchers call the day residue effect, the tendency for elements of recent waking experience, particularly emotionally significant ones, to appear in dreams within 1 to 2 nights of the experience. But these elements rarely appear literally. They appear transformed, recontextualized into new scenarios that preserve the emotional logic while discarding the specific content. This transformation is part of what makes dreams feel simultaneously familiar and foreign. You recognize the feeling, but not the setting. You know the person, but not in any way they would recognize. One of the quieter insights to emerge from dream research in recent years is the finding that positive emotional experiences are also processed during REM sleep, not just negative ones. Dreams with positive emotional content, dreams of connection, beauty, resolution, joy, serve the same integrative function as threatening dreams, helping the brain consolidate the emotional significance of positive waking experiences. The dream that moves you to tears upon waking, from relief, from reunion, from an unexpected moment of grace in a dream landscape, is doing the same work as the nightmare. The brain is tending to what matters. The narrative structure of dreams has been compared by some researchers to the structure of poetry rather than prose. Dreams do not build arguments or follow logical sequences. They juxtapose images, shift scales without warning, compress time, and generate meaning through association rather than through explicit statement. This poetic logic is not a defect of the sleeping mind. It may be one of its most sophisticated capabilities. The ability to generate meaning through the relationship between things, rather than through the explicit content of any single thing. The dream understands in a language that the waking mind has to translate. The experience of waking from a dream with a problem resolved, the so-called sleep-on-it effect, has a neurological basis. During REM sleep, the brain is more likely than at any other time to generate novel associations between memories and concepts that are not obviously related. This is because the inhibitory systems that normally constrain associative thinking during wakefulness are less active during REM. The brain is in a very real sense, thinking more freely, making connections that the waking mind would typically filter out as too strange, too tangential, or too unlikely to be useful. Some of the most quietly influential creative moments in human intellectual and artistic history have been associated with the hypnagogic state, or with REM dreaming. The structural model of benzene, attributed to Auguste Kekule, reportedly came to him during a half-waking dream of a snake swallowing its own tail. The sewing machine needle design, associated with Elias Howe, was attributed to a dream sequence involving spears with holes at their tips. These stories, whether precisely accurate in their details or somewhat mythologized over time, point toward a genuine capacity of the sleeping mind, the ability to recombine existing knowledge in configurations that waking attention has not considered. Research published in recent years has found that REM dreams show more socially focused content than waking thought. The dreaming brain spends a notable portion of its storytelling on social scenarios, interactions, relationships, conflicts, and reconciliations. This may reflect the role that REM sleep plays in processing social and emotional information, the kind that is most likely to carry weight across a human life. In this sense, the dreams you have about the people you love, the people you have lost, and the people you are still trying to understand are not random noise. They are the brain doing its most careful social work. The creative function of dreaming and the protective function of dreaming are not in conflict. They emerge from the same underlying capacity, the brain's remarkable ability, during REM sleep, to operate with fewer constraints on association and narrative possibility than it applies during waking life. The same freedom that allows the brain to generate a novel solution to a waking problem is the same freedom that allows it to construct an emotionally convincing scenario of falling from a great height. The dreaming mind is simply a mind with fewer filters, running the same basic operations with a wider aperture. The phenomenon of false awakenings, dreams in which the dreamer believes they have woken up and are going about their ordinary morning routine, only to discover they are still dreaming, offers a particularly vivid illustration of the brain's narrative authority. The brain can generate a complete simulation of the waking world, including the specific details of your bedroom, your body, and the ordinary sensations of getting up, without any input from the external world. False awakenings tend to occur during periods of disrupted sleep or high stress, and are more commonly reported by people who are prone to lucid dreaming. They are, in a sense, dreams about waking, the brain rehearsing the return to consciousness before it actually makes the transition. The content of recurring dreams, dreams that return in the same or very similar form over weeks to months or years, tends to center on unresolved emotional situations. Research has found that recurring nightmares, in particular, tend to feature the same emotional theme, even when the specific content varies: a persistent feeling of being trapped, being unable to protect someone important, or being exposed in a situation of vulnerability. The recurrence suggests that the brain has not yet completed whatever emotional processing the dream is meant to facilitate. The dream keeps returning not because the brain has forgotten, but because it has not yet finished. The relationship between recurring dreams and waking life situations is not always obvious. A person who repeatedly dreams of being lost in an unfamiliar building may not be literally navigating confusion in their waking life, but they may be navigating a sense of directional uncertainty, a feeling that the path forward is not yet clear. The brain does not dream in direct statement. It speaks in image, in feeling, in the language of situation rather than proposition. The interpretation of recurring dreams, approached with patience rather than urgency, can sometimes illuminate something the waking mind has been circling without quite arriving at. Sleep researchers have noted that the nightmares associated with grief follow a distinct pattern. In the period immediately following a significant loss, dreams often feature the lost person as present and alive, sometimes with a quality of normalcy that makes the return to waking painful. As time passes and grief is processed, these dreams tend to shift. The lost person appears less frequently in scenarios of ordinary presence, and more frequently in experiences with a quality of emotional resolution. Whether these experiences represent anything beyond the brain's own processing of grief is not a question science can answer, but the experiences themselves are consistent enough across populations to be worth holding gently. The neuroscience of the dreaming brain during adolescence is an area of growing research interest. Adolescents spend more time in REM sleep than adults, and the emotional intensity of adolescent dream content tends to be higher. This pattern aligns with what is known about adolescent brain development. The limbic system is highly active during adolescence, while the prefrontal cortex continues its decades-long process of maturation. The emotional intensity of adolescent dreams may reflect the brain's attempt to process the correspondingly intense emotional experiences of that developmental period. The dream is, as always, faithful to the waking mind that generates it. By this point in our journey, the understanding has shifted significantly. The dreaming brain is not a separate entity operating by different rules. It is the same brain, the same collection of structures, the same fundamental drives, operating with a different configuration of active and quiet systems. The brain that protects you, creates for you, processes your emotions, consolidates your memories, and tells you stories while you sleep is the same brain that you carry through your waking days. The boundary between the waking mind and the dreaming mind is more permeable, more gradual, and more continuous than the sharp division between sleep and waking might suggest. The theta rhythm, a particular pattern of brain oscillation occurring at 4 to 8 cycles per second, is prominent during REM sleep and has been associated with both memory consolidation and emotional processing. Researchers found that theta oscillations help coordinate communication between the hippocampus and the amygdala during sleep, facilitating the integration of emotional memory that is one of REM sleep's most important functions. When you are lying here, in the quiet dark, your brain is not simply resting, it is actively coordinating, integrating, and filing, running a kind of overnight maintenance that the waking day does not allow. The glymphatic system, the brain's waste clearance network, studied extensively since the early 2010s, operates most actively during slow-wave sleep, driven by synchronized oscillations in the brain's fluid dynamics. During REM sleep, this clearance appears to slow or pause, which may be one reason why both REM and deep sleep are needed across a full night. Different stages, it seems, serve different kinds of repair, and the brain cycles through all of them for a reason. The dream is one product of the sleeping brain. The clearance of the accumulated metabolic products of a day of thinking is another. Sleep serves more functions than any single theory has been able to capture. Research has established connections between sleep quality and immune response. During sleep, the body produces certain cytokines, proteins that support the immune system's ability to respond to infection and inflammation. In people with disrupted sleep, production of several of these proteins is reduced. The sleeping body is not resting from health. It is actively maintaining it. This physical dimension of sleep is rarely part of our conscious experience of dreaming, but the dream occurs within a body that is simultaneously doing the quiet work of keeping itself alive. The experience of time in dreams is related to, but not identical with, the experience of time during waking life. Research using signal detection experiments, in which participants agreed to signal during their dreams that they were performing a specific action, has found that the subjective experience of performing that action within the dream takes approximately the same time as it would in waking life for simple physical movements. But complex emotional sequences in dreams, scenes of confrontation, loss, reunion, or fear, often feel much longer in retrospect than the actual duration of the REM period suggests they should. The emotional density of a dream compresses or expands the subjective sense of how long it lasted. The geography of dreams, the settings in which they occur, has been studied in several large-scale dream content analyses. The most common settings in adult dreams are familiar indoor environments, followed by outdoor environments associated with the dreamer's waking life. Completely unfamiliar settings are less common than popular imagination suggests. The dreaming brain tends to set its stories in the places it knows best, then populate them with elements that do not belong there. This combination, the familiar made strange, is part of what gives dreams their distinctive character. The known world, rearranged by emotional logic. Sensory experience in dreams is predominantly visual, which aligns with the fact that the visual cortex is one of the most active brain regions during REM sleep. But research has found that people who have been blind from birth do not experience visual dreams. Instead, their dreams are organized around the senses they use most in waking life: touch, sound, taste, and smell. This finding is important because it confirms that the content and sensory modality of dreams are not fixed biological constants. They are shaped by the specific sensory architecture of each individual brain. The dream is always a portrait of the mind that generates it. The experience of emotions in dreams can be more intense than the corresponding emotions in waking life. Research has found that the subjective emotional experience of dreamers during REM sleep tends to be more vivid, more immediate, and more overwhelming than typical waking emotional experience. This intensity is consistent with the reduced activity of the prefrontal cortex during dreaming. Without the modulating influence of the rational, evaluating system, the emotions in the dream are experienced in something closer to their raw form, felt before they are interpreted, before they are placed in context, before the part of the mind that manages emotion has had a chance to arrive. The feeling of falling in a dream, one of the most commonly reported dream experiences, has been studied from multiple angles. One perspective focuses on the hypnic jerk at sleep onset. Another connects it to the vestibular system, which governs the sense of balance and spatial orientation and remains partially active during sleep. During REM sleep, the vestibular system can generate sensations of movement, rotation, and changes in spatial orientation without any actual physical movement occurring. The sensation of falling may, in some cases, to be the vestibular system generating a movement signal that the dream narrative then incorporates into a scenario of height and descent. The specific cultural forms that dream content takes vary significantly across populations. While the underlying emotional themes remain broadly consistent, a person in one culture may dream of being chased by wolves, while a person in another culture dreams of being pursued by spirits or strangers. The emotional structure, the threat, the chase, the desperate movement through a narrowing space is the same. The cultural imagery that clothes that structure varies in do. This suggests that the deepest grammar of dreaming is shared across all human beings, while the specific vocabulary through which that grammar is expressed is shaped by the individual life, the cultural context, and the particular stories the waking world has offered. And so the intellectual answer to tonight's central question is now fully in view. The brain wakes you before you die in a dream because it cannot, at any level of its functioning, in any state of consciousness, allow itself to treat your death as acceptable. Even in a story it invented, even in a world it knows is not real. The survival mechanism does not have an off switch for fiction. This is not a limitation of the dreaming brain. It is its deepest truth, a mind so committed to your continuation that it interrupts its own stories rather than complete the one that ends with you gone. Sleep doesn't come when you try to sleep. It comes when you stop trying. And this is exactly that moment. You have been listening, thinking, following, and now there is less and less to follow. The facts are simpler from here. The spaces between thoughts are wider. The distance between you and sleep is the length of one long, slow breath. You don't need to hold on to any of this. You don't need to remember. The brain that just spent an hour learning about itself will do what it always does when you finally let go it will dream. Let go. Every night, the brain generates a world. It populates that world with people, place, and events. It creates weather for that world. It creates emotion for that world. And then, every morning, it dissolves that world completely. What remains is not the world, but the feeling of having lived in it. The sleeping brain does not know you are asleep. The experience of a dream is, from the inside, simply experience. The logic is the logic of the moment. The people are people. The feelings are feelings. The brain does not place a label on what it generates that says this is not real. Across a lifetime, the average person spends approximately 6 years dreaming. 6 years of generated worlds. 6 years of stories the waking mind will mostly never remember. They happen anyway. They serve their purpose anyway. The brain does not require your witness to do its work. The most common emotion reported in dreams is not fear, it is anxiety. A lower register, more pervasive emotional tone that is less acute than fear but more persistent. The dreaming brain is, for many people, not primarily frightening. It is primarily uncertain. It generates, over and over, scenarios in which the outcome is not yet known. This persistent uncertainty in dream content may reflect the fundamental orientation of the brain toward the future. The brain is a prediction machine. It spends its waking hours modeling what will happen next, preparing responses, calibrating expectations. During sleep, this same forward orientation continues, expressed as scenarios of unresolved threat, of unknown outcome, of paths not yet taken. There are people who report never dreaming. What research consistently finds is that these individuals are not dreamless. They are simply not recalling their dreams. The REM architecture of their sleep is normal. The brain is generating dream content, but the consolidation of that content into accessible memory is not occurring. We are all dreaming. The difference is only in what we carry back. The earliest recorded dreams in human history are found in ancient Mesopotamian texts, some of which are more than 4,000 years old. These texts describe dreams with the same structural features that modern researchers identify: vivid imagery, emotional intensity, narrative ambiguity, and the persistent sense that the dream means something. The dreaming mind has been trying to understand itself for as long as there have been minds to dream. In many ancient cultures, dreams were considered a form of communication. From ancestors, from deities, from the future, the interpretation of dreams was a specialized skill, practiced by priests, shamans, and temple oracles. Dreams were not dismissed as random noise. They were treated as information. Modern neuroscience has not arrived at the same conclusion, but it has arrived at a similar respect. The dream is not meaningless. It is the mind in its most unguarded state, speaking in its most honest language. The quality of sleep, not just its duration, but its architecture, its depth, and the completeness of its cycles, has a profound effect on emotional regulation the following day. Research consistently shows that people who experience disrupted REM sleep are more emotionally reactive, less able to modulate their responses to difficult situations, and more likely to interpret ambiguous moments as threatening. REM sleep is not a luxury added at the end of a good night. It is the portion of sleep most directly responsible for the emotional tone of the day that follows. The relationship between sleep and compassion has begun to attract research attention. Studies have found that disrupted sleep is associated with reduced prosocial behavior, reduced willingness to help others, reduced empathy, reduced emotional resonance with other people's distress. The sleeping brain, in processing its own emotional experience, may be doing something that supports the capacity to meet the emotional experience of others. Rest is not selfish. It is one of the foundations of the ability to be genuinely present with another person. The transition from waking to dreaming is not a sharp border. It is a gradient, a slow relaxation of the waking mind's tight hold on the linear, sequential, causally structured experience it maintains during the day. As you move towards sleep, the associations become looser, the images more vivid, the emotional logic more primary. By the time the dream fully assembles itself, the waking mind has stepped far enough back that the dream has room to become its own world. You are in that gradient right now. The space between what you just heard and what you are about to hear, the space where the thought you are following dissolves before you quite reach its end. That space is not empty. It is the beginning of something. Your brain creates entire worlds while you sleep, every night. During REM sleep, your mind constructs vivid experiences from memory fragments, emotions, and abstract patterns. Characters appear, conversations unfold, and landscapes emerge, all generated from within. These dream worlds feel real in the moment, complete with sights, sounds, and even physical sensations, yet they vanish upon waking. Like morning mist, the sleeping brain is not resting, it is creating. The moment of waking before the dream's worst moment is, in the end, a form of tenderness. The brain, with everything it has, all its ancienne circuiterie, all its accumulated survival wisdom, chose you, interrupted its own story to make sure you were still here, pulled you back from the edge of the narrative it invented, simply because it could not let that narrative end the way it was heading. So the question this video began with has been answered, not just intellectually, but in the quieter way that facts, when they accumulate slowly enough, become something more than facts. You wake up before you die in a dream because your brain cares about you in the oldest possible way reflexively, without calculation, without condition. It has been doing this every night of your life. The brain you carry to sleep tonight has done this thousands of times. It has caught you, gently, at the edge of every falling dream. It has interrupted every narrative that was heading somewhere it could not allow. It has held the thread of your continuity through every night you have ever lived. And it will do it again tonight. What the science of dreaming ultimately reveals is not a strange or alien process operating in the background of consciousness. It reveals something familiar, something recognizable, a mind that cares about the same things you care about: safety, connection, continuity, meaning, and pursues them even in the absence of your conscious direction. The dream that unsettled you, the dream that woke you with a sharp breath, the dream you wish you could forget. That dream was not evidence against you. It was evidence for you. Evidence that the brain generating it considered you important enough to simulate a world around, important enough to interrupt when the simulation became too much. Sleep is not the absence of consciousness. It is another form of it, one that is oriented differently, structured differently, and committed to purposes that the waking mind only partially understands. The two forms of consciousness are not separate lives. They are one life, seen from two different angles. Both of them are you, in the space between one thought and the next, between one breath and the next, between the last word of a sentence and the first moment of sleep. The brain is still watching, still tending, still committed to the task it has never once abandoned. You do not need to protect yourself tonight. That work is already being done. The dreams you will have tonight are already waiting, assembled from everything the day left behind, everything the week accumulated, everything the year has been building toward its quiet resolution. You do not choose them. You do not direct them. You only receive them. And then, most mornings, you release them. Let them dissolve back into the brain that made them, leaving only the feeling of having been somewhere that mattered. You have been somewhere that matters every night of your life. You just rarely remember it clearly enough to be grateful. But it happened. It happens. And it will happen again tonight. In the darkness behind your closed eyes. In the world the brain constructs without your help. Whatever you are carrying into sleep tonight, whatever is still turning in the background of your thoughts, whatever has not quite resolved, whatever still feels too large for the space you have to hold it in, the brain knows what to do with it. It has been doing this since before you knew what sleep was. The question of why you wake up before you die in a dream has an answer. But the deeper question, the one the answer opens, is this: what does it mean to live inside a mind that cannot stop caring about you, even while you sleep? Even in a story it knows is not real. Even when no one is watching. The real discovery tonight is not about death in dreams. It is about what the dreaming brain reveals about the nature of the brain itself. A mind that goes on caring in the dark. That interrupts its own fictions to keep you safe. That works through the night on your behalf, asking nothing in return. That has been doing this, quietly, faithfully, without a single night off, for every night of your entire life. You are held by something that does not sleep. Rest now. You are safe. And so our quiet journey through the dreaming mind comes gently to a close. We began in the most familiar place, that gasping, jolting moment of waking right before the dream's worst conclusion, and discovered that it was not a glitch. We moved through Ravonsuo's threat simulation theory, the idea that the brain rehearses danger precisely because it cannot afford to be caught unprepared, and found it offered not a frightening explanation, but a strangely comforting one. We arrived at image rehearsal therapy. The finding that the brain, which generated the nightmare, is the same brain that can be guided, with patience, toward a different story. And somewhere in the space between those facts, the answer became something quieter than a scientific finding. It became something closer to a recognition. The brain that stops the dream before the fall reaches the ground has been doing that every night of your life. Dreaming reminds us that the mind never fully goes off duty. Not in the way that truly switches off. Much of the most important work consciousness does happens in silence, beneath the threshold of awareness. In the darkness behind closed eyes, the dream reveals the care that has always been running in the background, patient, faithful, and entirely on your behalf. Without the dreaming mind, the waking mind would be carrying everything alone. In these final minutes, take the deepest breath you can. As deep as possible, think about unity. Think about the fact that the part of your brain that invented the danger in the dream is the same part that stopped it. Protector and storyteller, wound together in the same tissue, serving the same purpose. There is no part of you that is working against you. Let your entire being dissolve into the space between one dream and the next, where the story has not yet formed, where the brain is simply breathing, simply holding, simply present, where the boundary between you and sleep is no longer a border, but a gentle gradient that you are already crossing. Prepare for deep sleep. No boundaries left, only peace. If these quiet facts about the dreaming mind helped you see your own mind a little more gently tonight, perhaps share this softly with someone who wakes afraid from their own dreams. It might be exactly the reassurance they have been looking for. A gentle like or subscribe helps other sleepless souls find their way here. One dreaming soul at a time. Whatever you have been turning over today, those half-formed thoughts, those moments you keep returning to, you don't need to carry them into sleep. They will still be there in the morning. Tonight, you belong only to yourself. You have traveled inward tonight. Through corridors most people never pause to notice. You touch the architecture of how the sleeping mind cares for you, and found it more patient, more faithful, more constant than perhaps you knew. You can allow these thoughts of dreams to fade now, like that last image at the edge of waking, present for a moment, then softer, then simply part of everything, leaving only the quiet, unheld calm behind. Let your breathing deepen. Let your body feel heavier, as if the same quiet current that carries you into every dream has finally found you here, unhurried, exactly where you are, and is simply holding you. If sleep comes, let it carry you the way consolidation does, not with force, but with quiet intention, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the dreaming mind will still be there, still tending, still weaving, still catching you before the fall, still becoming. But tonight belongs to stillness. Rest well, gentle explorer, and remember, it dreams of danger only because it cannot lose you. Good night.